Okay, so this problem is about a 5-kilogram crate that is pulled with a force of 33 newtons. Now, that 33 newtons is acting towards the right, and the coefficient of kinetic friction is given. Oops, I changed colors. Mu k is actually, that's what we're looking for. What is mu k? What is the coefficient of friction if the crate, if it's moving at a constant velocity of 2.2 meters per second. So the way we're going to do this is, the first step is we're going to draw a free body diagram, and we're going to draw the crate. Now that doesn't really look like a very straight line. Let me try that one more time. And there's the crate. Now we have to put the free body diagram's force vectors on the plate. This is the vector that's the applied force. And the way to figure out what all these forces are is to use the magic sentence, what's touching it plus gravity. So obviously in this case the ground is touching it, and the ground does create two forces. One of them is the normal force, and the other one, which is opposite to the direction of motion, is the force of friction. The magic sentence is what's touching it plus gravity, and so those are all the forces on this object. Now, if we now say sum of the forces is equal to F net, we can now say, okay, we need to pick a positive direction, and I'm going to pick this direction as being positive. So you can see that in fact it's negative force of friction plus applied force is going to equal F net. Now the other thing is, this is in the horizontal direction. Okay, so we can say horizontally. But vertically, there is no acceleration. Vertically, the acceleration is 0. It's not moving up or down. In fact, not only is that true, but also, if you look here, it says constant velocity. Well, that means that horizontally, the acceleration is equal to 0 also. So let's first take a look at this. By the way, was the horizontal analysis for F summation of the forces. We can also do the summation of the forces is equal to F net in the vertical direction. And if we do that, and we have to specify our positive direction for the vertical, and that's up. So that would be Fn minus mg equals ma again, which is F net. But you realize this is 0 because a is 0. So in fact, what this equation ends up being is Fn equals mg. If you take the mg to the other side, it becomes positive. We can actually do the same thing here, because this equation also equals ma, which equals 0. Let's draw a line here. And so in fact, since a is also 0 horizontally, see, so the horizontal one's over here, then we can take this term to the other side of the equation, and it becomes F applied equals force of friction. And now we can say to ourselves, well, what is the force of friction? That's equal to mu Fn. And so this is still applied force. And what we're going to get with this is we can replace Fn with mg. And so we'll have applied force equals mu mg. And then, what are we looking for? Well, the question is asking, what is mu k? And all we need now is to calculate mu. And the way we're going to do that is we're going to substitute in our values. Well, first we'll solve for it algebraically. And we'll get applied force divided by mg is mu. And now if we solve for that, the applied force was, I believe, 33 newtons from the question right there. And divided by, I believe it was 5 kilograms times 9.8 newtons per kilogram. And we get an answer of 0.67, which is equal to mu k. And that's our final answer. I hope you've enjoyed this question. See you next time.